Hello. So these notes are about organizing data, chapter 12.2. Um, so it is very difficult to analyze and interpret raw data or make meaningful observations about a group of numbers. We use charts and graphs to help us visualize data sets and put them into a useful context. Um, Frequency distribution is what called a listing of the observed values and the corresponding frequency of occurrence of each value. So what we're going to do is we're actually going to make a frequency chart to organize this data. So we have a group of male students that are randomly selected and asked their heights in inches. The results are listed below. Use the data to answer the questions. So and then we've got questions down here. So first we're going to make that frequency chart to organize the data. So what we're doing here is I always make a chart that's too big. So let's see. We'll have the height over here in inches, and then we'll have the number of students on the other side. So we need to start looking for the shortest height. And when we're, going through here, we can see we have a 66 there. We have 67. Well, it looks like 66 is the shortest height. So I'm going to cross out the 66, and I don't see another 66 here. So that means that we have one student who is 66 inches. Then I'm going to move on to the 267, and I'm crossing them out as I'm going to make sure that I do pick each one that is that same height. So 67, we found 3 students. That way I don't miss anything. Next one is 68. So we have 1 and 2 students that are 68 inches tall. Next one is 69. And when we go through this list here, we don't see a 69 listed. So there are 0 students that are 69 inches tall. 70, we have 1 and 2, I believe, that are 70. 71, 1, 2, 3, right there. 4, 5, and 6. So 6 students that are 71 inches. 72, 1, 2, 3, 4, 5, 6, and 7. Almost missed that one. This is why we are crossing them out as we're going. 73, 1, 2, and 3. Is there another? There's a 4th one. Okay, 73, 4 students. And then 74, we have 1 student. And 75, we have 1, 2. So this is our frequency chart. And now we're going to start answering these questions here by looking at the frequency chart. So our first question is, what is the tallest height? So who is, how many inches is the tallest? Well, the tallest here is 75 inches. The shortest is going to be up here, which is 66 inches. So it's much easier when we have them in order to answer the questions than trying to figure out from just the data here. Okay, most common height. So most common height would be the height that has the most students. So right here we have 7 students. So our most common height is 72 inches. Second most common height, right here we have 6, so that would be 71 inches. Well, least common height, we have, well, we don't have anyone in 69, not at all. It's not listed. But least common height, where we have one student, is 66 inches and 74 inches. Total, how many students do we have in total? 4, 6, 4, 6, 12, 14, we have 14, 18, and that's a 10, 28 students total. Now, which heights weren't listed? Well, of course, there were not listed 65 and shorter. So 65 inches and shorter. We didn't have 69 inches. That was not listed on there. And then 76 and taller. So which heights showed up multiple times? Well, that we're going to look at. We have 67, we have 68, 70, 71, 72, 73, and 75. All of those heights were listed more than once. Overall, are the students shorter, taller, or in between? So now we need to kind of look at how, what number of students are where. So if we do have, like, we can see 71 and 72 are the ones that have the most. That is sort of in between. But then if we start going, we have 4 students that are 73 and we have 2 students that are 75. So they are kind of on the taller side over here. Okay, let's move on to page number 2. So we have group frequency distribution, and there's some terminology with the definitions that I've already written that you're going to need to write in your notes. So a class is grouping of values. Lower class limit is the smallest value in class. Upper class limit is the greatest value in class. Class width is the difference between the lower limits of the first 2 classes. And that should be enough. Midpoint of a class or class mark, the lower class limit plus the upper class limit divided by 2. And we'll look at what these mean. Modal class, the class with the greatest frequency. So what we're going to do is we're going to use the data that we had on page 1 and make a group frequency distribution chart for that data. So we're going to take this here and make a group frequency distribution chart. So how do we do that? We're going to split this data into groups. And then, so basically the distribution chart looks similar. Here are our number of students. But instead of just using this one height, we're going to group them. And what you want to do is you want to have at least kind of like 5 groups. So looking at these heights, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to group them in within like 2 heights. So 66 to 67. And then 68 to 69, 70 to 71, 72 to 73, 74 through 75. So those are our groups. And now we're gonna, look how many students are in each group. So 66 inches, we have 1 student, and 67 inches, we have 3 students. So this is gonna be 4. 68 and 69, 2 plus 0 is 2. 70 and 71, 2 plus 6 is 8. 72 and 73, 7 plus 4 is 11. And then 74 and 75, it's 3 students. So now, especially if we think about, are the students overall taller, we've got, more students down here where they're taller than up here now that we've grouped them. So it's just a different way of looking at the data. Next, we need to identify the modal class. The modal class is the one with the greatest frequency. So this one has 11 students, so that is our modal class, 72 through 73 inches. Next, we need to identify its lower and upper class limits. So lower class limit is the smallest value in class, and upper class limit is the greatest value in class. So what we're going to do here is our lower class limits are these ones here. So 66, 68, 70, 72, and 74. Where our upper class is over here. So that would be 67, 69, 71, 73, and 75. And now we're going to identify its midpoint. So midpoint meaning the midpoint of a class. The lower class limit plus the upper class limit divided by 2. So I'm going to rewrite these over here because it's just easier that way. So we have our lower class. That is 66, 68, 70, 72, and 74. And then we have our upper class. And those are 67, 69, 71, 73, and 75. So now for the midpoint, we're going to add these. So 66 plus 67 and divide by 2. And when we do that, 66 plus 72, not 72, 66 plus 67, and make sure you hit enter, divided by 2 is 66.5. So that is the midpoint for this group here. Next one would be 68 plus 69 divided by 2. So 68 plus 69 divided by 2 is 68.5. So notice what happens here. It's in the middle in between these two. So of course it depends on the lower and the upper class limits, what your midpoint is going to be. So now without having to calculate, we know that it's 70.5, this one is 72.5, and this one is 74.5. So now we're going to answer again, overall, are the students shorter, taller, or in between? And I did kind of mention that, on the taller side, but if we take a good look at this one here is in the middle, right? We have two on the, two groups on top of it and 2 groups on the or below it. So basically the 11, if we take these, and even if we take the 2, it's kind of more in between with this grouping. So it looked different when we did it. We did the groups instead of just listed the heights. So for this one, it has to be in between because we've got more on 8 than we have more. 8 is more than 3, so we have more in the 70 through 71 than 74 through 75. Okay, next we're going to go ahead and make a histogram. So we're using, again, the same same values. So the same, the height of the students and number of the students. So a histogram measures frequency used for continuous values, just like height, for example. So bars do touch. So let's look at this. We would put the number of students on here on the y-axis, number of students. So we're going to start with a 0, and then we have 1. We have 2, 3, 4, 5, 6, and 7 students. And then we're going to put the heights over here. And heights are in inches. And what I'm going to do is I'm going to start with the 66 because that's what we're starting with. 67, 68, 69, 70, 71, 72, 73, 74, and 75. Again, the bars do touch because it is a histogram. So let's see if I can fit both of these papers here. So we're going to start with the 66, and that is 1 student. So that means that we're drawing 1 student over here. 67 is 3 students. And actually, you know what? You should have, instead of having the numbers on the line, they should be in between. I'm sorry. I wasn't paying attention to what I was doing. So they should be in between in a histogram, not on the actual grid. So 66. Next one is 67, and we have 3. So 67, we go all the way up here. And there's that. Next one is 68. And we have 2, so 68 here. 69 has none, so we're going to leave that as it is. 70, we have 2 students, so 70 goes up here. And 71, we have 6 students, goes all the way up here. 72 is 7 students. So that one goes all the way up here. 73, 4 students. So again, the 4 is here. And 74 is 1 student. And 75 is 2 students. So there's our histogram. Now, so again, histogram is for continuous values, so bars do touch. We have another one. So yeah, this one was histogram. which is called a bar graph. That measures frequency used for discrete values, so bars do not touch. So on this number 4, we're supposed to make a bar graph representing the class result of favorite type of fruit, citrus, berries, apples, bananas, and other. What I'm going to do is I'm just going to make up numbers here as I go, and then we're going to draw the bar graph. So let's say that we have 3 students that like citrus. We have, so it's the favorite type of fruit. We have, for example, 10 who like berries, 6 who like apples, and 4 who like bananas. So we're going to put the number of students again here. On this side here. So we're going to start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to do the fruit down here. And again, notice that the number of students are on that line, because that's where it kind of ends. Whereas in these berries, just like the heights are between the lines. So I'm going to put citrus here. I'm going to do berries here. Apples. Bananas. And I'm going to leave it at that. And again, notice that what I did is I did every other because the bars do not touch. These are all discrete values. They are separate from each other. There's not a combination of citrus berries. Well, there might be nowadays, but we're talking about different ones. So it doesn't, like with a height, you're kind of, you can be in between 66 and 67. Here, you're not in between a berry and an apple, or between an apple and a banana. So they're totally separate. So citrus, we have 1, 2, 3. So we go up here. Berries, we have all the way 10. So we go all the way up over here. Apples, we had 6. So 1, 2, 3, 4, 5, 6. And bananas, we have 1, 2, 3, 4. So this is a bar graph. This is a histogram. Know the difference between those two. And actually on the next page, we do have a question. What is the difference between a histogram and a bar graph? Which is appropriate for qualitative data like eye color, and which is appropriate for quantitative data like grades. So let's go ahead and compare those again. A histogram presents numerical data. So it gives us, or when we use it where we have quantitative data. Quantitative. What am I missing here? I'm missing a T-I. T-I-V-E. Sorry. So histogram presents numerical data, which is the quantitative data like grades. So this would be the grades. And remember, in this one, the bars touch. In histogram, we have the bars touch. Again, we can have grades. We don't only have like a 90 and a 95. We can have a 92 or an in between as well. For the bar graph, that presents more of a in categories. Okay, I'm gonna need to get a drink. Excuse me for a second while I feel like I've got something in my throat that's causing me to cough. Okay. So bar graph is more of the qualitative data. So I color, for example. And for this one, the bars do not touch. Okay, for this frequency polygon of data, what we're going to do is we're actually going to use the histogram that we drew instead of drawing another one. So we're going to use this data here. And what that frequency polygon of the data means that it is a line drawn here through these through the midpoints. So we're going to start with the midpoint, or the 66, and go to 67, and then 68, 69, 70, 71, 72, 73, 74, and 75. So this line is a frequency polygon of the data. So it's this one. So we did it in number 3. Okay, let's look at number 6. A group of test grades are shown below. Make a stem and leaf plot for the data and answer the following questions. So a stem and leaf plot. A stem and leaf plot means that we are just drawing a line in the middle, and then we're going to start with the smallest grade here, or the lowest grade, smallest number, which would be 47. And what we're going to do is we're going to put the 4, so the 10s are on this side, and the 1s are on the right side. So a 7 over here. Now, we don't have another one that has or starts with a 40, so we're going to go on to the next one, which would be, we have a 57 and a 58. So I'm going to put the 50 only once on the left side, but then we have a 57 and a 58, so I'm going to put a 7 and an 8 on the right side. For 60s, we have a 62, we have a 67, a 63, and another 63. So notice that I'm writing all those ones on this side, and it doesn't matter. They're not in numerical order. They're not in an increasing order. It's okay for, it to look like this. Then we have our 70s. So 77, 79, 70, 75, and 74 is what I meant to do. Next one is 80s. So 8, 81, 87, 80, 83, 88, and that's it. Then we have our 90s. So 9, 96, 96, 93, 91, 91, 96, 93, and 96. That's it. And then for our 100s, of course, now we need to write 10 on here. And we're going to put 0, 0, and 2. So this is what's called a stem and leaf plot. We have the stem, which in this case are the 10s on the left side, and then we have the 1s on the right side. So now we're going to answer questions based on this, what we have here. So notice that how much easier it is again to look at this than, try to figure out from those grades. So how many F's were there? 1, 2, and 3. So 1, 2, 3. 3 F's. 59 and below are F's. How many A's were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 A's. What was the most common grade? Well, if we look at this, we have 10 A's, we have 1, 2, 3, 4, 5 B's, 1, 2, 3, 4, 5 C's, and then 4 D's. So A has to be the most common grade. What is your overall impression of their performance? Well, if the most common grade is A, it has to be excellent. It's very rare to have, well, yeah, it's very rare to have 10 A's. And I didn't even, how many students did we have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 plus 10 is 27 students. So yes, it is rare to have 10 A's out of 27 students, which is great. I mean, their performance is excellent. Okay, then we're going to jump into another kind of a graph. A circle graph, a pie graph, whichever you want to call it. There's several names for this one. And we have Ringling Brothers and Barnum and Bailey Circus, which of course doesn't perform anymore. But we're going to look at, this problem still. So we can think of in the past, 800 people who attended the circus were asked to indicate their favorite performance. The circle graph below shows the percentage of respondents that answered tigers, elephants, acrobats, jugglers, and other. Determine the number of respondents in each category. So our total people is 800. If we need to determine how many people did it, we are going to calculate, for example, tigers, 38% of 800. So remember that of is a multiplication, and we're going to make this into a decimal, so 0.38, not 0.0. Oh, I've got to move the point here, so 0.38. 38 divided by 100 times 800. Where's my calculator? Here we go. 0.38 times 800 is 304. So 304 out of those 800 thought tigers were the best. Elephants, 26%. Same thing, 0.26. 26 divided by 100 times 800. And so 0.26 multiplied by 100 is 208. Acrobats, 0.17 times 800, that would be 136. Jugglers, 14%. Again, 0.14 times 800, and that would be 112. And then other, 5%, 0.05 times 800 equals 40. So here's how a circle graph works. It's usually given in percentages. Sometimes you'll see the numbers like 304, 208 on there, but a lot of the times it's percentages, because it's easy to show this whole circle is 100%, and then the little, all of these should add up to 100%. Okay, this is it for this lesson. As usual, if you have any questions, let me know. Bye.